The purpose of this learning module is to present the life cycle of a flood study. This presentation will cover RiskMAP program details, the RiskMAP timeline, the RiskMAP mapping process, RiskMAP regulatory and non-regulatory product, and mitigation. FEMA's Risk Mapping Assessment and Planning Program, also known as RiskMAP, is taking a watershed approach to develop non-regulatory products, the Flood Risk Report, Flood Risk Database, and Flood Risk Map, and regulatory products including the Flood Insurance Rate Maps, Flood Insurance Study, and Flood Database. The goal for these products and datasets is for state and local officials to take actions that lead to flood risk reductions, sometimes referred to as mitigation. RiskMAP provides communities with flood information and tools to use to enhance mitigation plans and other management activities and better protect their citizens through more accurate flood maps, risk assessment tools, and outreach support. Conducting these studies on a watershed basis will assist the communities, Kentucky Division of Water, and FEMA to better understand the contributing factors to flooding, risks, watershed needs, and mitigation options. Risk mapping analysis and assessment applies engineering and planning practices in conjunction with advanced technology tools to identify hazards, assess vulnerabilities, and develop strategies to manage the risks associated with natural hazards. Risk reduction planning works to reduce risk to life and property through the use of land controls, building practices, cost-effective mitigation grants, and other tools. These activities address risk in both the existing built environment and in future development, and they occur in both pre- and post-disaster environments. Risk insurance helps reduce flood losses by providing affordable flood insurance for property owners and by encouraging communities to adopt and enforce floodplain management regulations that mitigate the effects of flooding on new and improved structures. Ultimately, through collaboration with state, local, and tribal entities, RiskMAP will reduce losses to life and property through effective local mitigation activities enabled by quality flood hazard data, risk assessments, and mitigation planning. The RiskMAP will establish an integrated flood risk management approach that leverages the existing data from flood map modernization. RiskMAP will provide an integrated national assessment of flooding risks based on digital flood hazard data and web-accessible data. This information will enable communities to develop mitigation plans and make informed risk management decisions that maximize loss reduction. As noted on this slide, the timeline for RiskMAP activities is 3 to 4 years. This translates into the development of relationships in the watershed and continued communication and coordination throughout the life of the project. This is quite a departure from map modernization activities, where the focus was to create updated FIRMS and FIS reports. RiskMAP takes a more holistic view of the watershed characteristics that contribute to flood risks and serves to communicate those risks and identify actions that will ultimately reduce that risk. Components of the RiskMAP process include traditional engineering analysis and mapping products combined with the risk assessment and mitigation information. The planning and budgeting phase finalizes the mapping needs of each community, the final budget for the watershed study, and the final scope of work. During the discovery phase, the project team gathers information about local flood risk and flood hazards, engages local watershed stakeholders, initiates risk assessment, mitigation planning, and risk communication discussions. The data development and sharing phase is when engineering analysis is performed to produce updated floodplains. RiskMAP products are developed and introduced to communities. Communities and mapping partners can then prepare for the upcoming resilience meeting. The risk awareness and mitigation outreach focuses on the development of strategies to reduce flood risk and improve resilience, identify resources to facilitate implementation, and discuss communication roles and responsibilities. Preliminary flood insurance rate maps are introduced to the community for review during the proposed NFIP map changes and impacts phase. The due process and path forward phase allows communities to adopt new FIRMS and to continue to build a more flood-resistant and resilient watershed. In collaboration with federal, state, and local stakeholders, FEMA developed a strategy that moves away from county-wide mapping to watershed-based mapping, a much broader and integrated approach. In order to be successful, RiskMAP efforts must be combined and resources used efficiently towards a common strategic direction. These objectives drive FEMA's mitigation efforts, FEMA collaboration with partners, and program delivery to impacted communities, and work toward an integrated RiskMAP effort. The factors to evaluate are 1. Programmatic metrics, 2. The current availability of data, 3. The level of risk, and 4. The level of need. The objective of the evaluation step is to understand the risk and need data at the various watershed levels. During the discovery process, the Kentucky Division of Water will be collecting a lot of data from the stakeholders. This data includes the following: areas of recent or planned development, areas of high growth or other natural land changes such as wildfires or landslides, locations of other ongoing studies, projects and studied stream reaches that have been modified since the effective map and require an updated study, an example would be highway improvements, or locations of future topographic data acquisition, proposed discussion areas, problem areas, areas of proposed mitigation projects, land use and soil information, such as information from existing or future land use maps, zoning maps, or other sources, and hydraulic structures such as bridges or culvert with inspection status if available. Data collection during the discovery phase gathers information about local flood risks and flood hazards within a watershed. It engages local watershed stakeholders, initiates risk assessment, mitigation planning, and risk communication discussions. This is a critical point during the RiskMAP study process for local officials to provide data. Data needs include, but are not limited to, terrain data such as LiDAR, boundary, hydrography, and transportation layers, regional mitigation plans, floodplain ordinances, areas of known flooding, regional economic plans, areas where flooding or other natural hazards are an issue, planning, zoning, and stormwater ordinances, and parcel and building footprints where available. Communication is essential to the RiskMAP process. Throughout the life cycle of a flood study, the mapping partner and watershed stakeholders will meet to acquire and review community data, review mitigation opportunities, preview preliminary products, and plan for map adoption. Those meetings are the Discovery Meeting, which is a working meeting where stakeholders engage in quality watershed discussions and review risks in the watershed. The Flood Risk Review Meeting is optional but strongly recommended if appropriate for the project. This is a technical and engineering-focused meeting that gives community officials the opportunity to review the draft RiskMAP products where they are scoped for the watershed. That gives community officials the opportunity to review the draft RiskMAP products when they are scoped for the watershed. The purpose of the Resilience Meeting is to continue to build local capacity for implementing priority mitigation activities within the watershed. For RiskMAP projects that include regulatory map and flood insurance study report updates, the CCO meeting and FloodMAP open house will be the last official set of meetings that the project team will have with communities during a RiskMAP project. These are two distinct meetings. The CCO meeting is a meeting held by the project team for the local officials in communities receiving new or updated regulatory products, the flood insurance rate map and flood insurance study report. The open house is held by the project team and community officials, and the objective is to present the preliminary firm and FIS report to the public. Field survey is the collection of data required to digitally represent field conditions collected, such as dams, culverts, bridges, transects, structures, and channels, measuring the physical structure to model how the structure affects stream flow. The level of data collected depends on the mapping needs of each stream determined during the planning phase. Data collected during the field survey will be included in the engineering analysis. The survey data collected depends on the type of FEMA study. There are two types of studies, detailed study and approximate study. A detailed flood hazard analysis will generally include a detailed hydraulic analysis, digital topographic data, cross-sections to include underwater elevations, and surveys of hydraulic structures are required. For an approximate flood hazard analysis, less data is collected. Cross-sections may be interpolated from contours on topographic maps, and underwater elevations may be interpolated from upstream and downstream data, assuming the channel bottom information has not changed significantly. Topography is a three-dimensional arrangement of physical attributes, such as shape, height, and depth of a land surface in a place or region. Physical features that make up the topography of an area include mountains, valleys, plains, and bodies of water. Applied to the mapping process, topography is a digital representation of terrain. Terrain data sets are used to digitally model how water within the study area moves over land. Historically, topographic data was collected by surveyors on the ground. A new format, LiDAR, is plane collected data. LiDAR is the acronym for light detection and ranging. LiDAR data is quickly collected, highly accurate, and can be transformed into different types of spatial terrain data sets. Due to its high level of accuracy, LiDAR can be used in many different projects. The cost can often be leveraged in conjunction with other mapping, planning, and engineering projects to minimize data acquisition costs. Terrain data sets such as digital elevation models and triangulated irregular networks can be created using LiDAR data. More accurate topographical data allows for more accurate floodplain delineation. Hydrologic analyses are studies of the amount of water flowing in a stream during flood events. Generally, flood insurance studies, or FIS, are concerned with peak or maximum rates of flow, discharges, in streams for multiple recurrence interval flood events, 50, 10, 2, 1, and 0.2% annual chance are the return periods commonly analyzed. The peak discharges are typically measured in cubic feet per second, or CFS. A recurrence interval flood event is the name given to a discharge that has a percent chance likelihood of being exceeded in T number of years. For example, a discharge associated with a 1% chance probability of exceedance will be expected to occur one time in 100 years, using the formula percent chance equals 100% times 1 over T. Because a chance probability of exceedance is only a statistical likelihood, it is possible, however, that a 100-year recurrence interval event may occur more than once in 100 years. A hydrologic study is the study of the movement, distribution, and quality of water. The hydrologic cycle does not stop at political or corporate borders. The boundaries of RiskMAP study areas are defined by the watershed. For RiskMAP studies, the United States is divided and subdivided into successively smaller hydrologic units which are classified into 4 levels: regions, subregions, accounting units, and cataloging units. The hydrologic units are arranged within each other, from the smallest, cataloging units, to the largest, regions. Each hydrologic unit is identified by a unique hydrologic unit code, or HUC, consisting of 2 to 8 digits based on the 4 levels of classification in the hydrologic unit system. Hydraulic analyses are studies that determine the water surface elevation or depth of streams. Flood insurance studies are primarily concerned with the 1% annual chance recurrence interval water surface elevations, otherwise known as base flood elevations, or BFEs. Analyses are based on model inputs such as discharge values, channel cross-section geometry, channel roughness coefficients, slope values, and distances between cross-sections, downstream and upstream boundary conditions, and conveyance and storage characteristics. Datasets produce base flood elevations, or BFEs, and additional elevations for other recurrence intervals, water surface elevations, and stream profiles. Digital floodplains are produced by overlaying hydrology and hydraulics information with the digital terrain dataset. Mapping specialists use cross-section widths and digital elevation data to delineate floodplain boundaries. Stream by stream, floodplain datasets are mosaicked together to produce a watershed's flood hazard area included in the flood insurance rate map database. Up-to-date digital flood maps provide many benefits: accurate flood hazard information for establishing appropriate actuarial insurance rates, standards for flood hazard and other datasets, land use planning, and hazard data that informed emergency management and environmental planning. The National Flood Insurance Reform Act of 1994 requires FEMA to assess the need to revise and update all floodplain areas and flood hazard zones at least once every 5 years. The 5-year cycle ensures the NFIP flood map inventory adequately reflects today's flood hazards. Floodplain mapping pre-RiskMAP generated 3 types of products: the firm database, the flood insurance study, and the flood insurance rate map. These are all regulatory products used for the floodplain management and to establish mandatory flood insurance purchase requirements. These products will continue to be generated from the FEMA watershed studies. A flood insurance rate map, or FIRM, is the official map of a community on which FEMA has delineated both the special hazard areas and the risk premium zones applicable to the community. It is used by private citizens, insurance brokers, community officials, lending institutions, and federal agencies. A flood insurance study, or FIS, is the report that contains information regarding flooding in a community and is developed in conjunction with the flood insurance rate map. The flood insurance study frequently contains a narrative of the flood history of a community and discusses the engineering methods used to develop the firms. The study also contains a summary of discharges, floodway data, and flood profiles for studied flooding sources that can be used to determine base flood elevations for some areas. The Flood Insurance Rate Map database stores the Geographic Information System, or GIS-based attributes of the digital firms and has specific requirements for database design considerations, technical content, and metadata. The firm database is designed to facilitate access to, as well as collection, storage, and processing of, data developed by FEMA for the NFIP. The firm database content will vary based on the data available and/or developed for a particular flood study and mapping project. All firms will contain certain standard features: a base map that is distributed with the digital files, the features shown on a printed flood insurance rate map, such as floodplain boundaries, base flood elevations, regulatory floodways, cross-sections, and benchmarks, an electronic flood insurance study report text, tables, and flood profiles, and Federal Geographic Data Committee compliant metadata. In addition to the elements listed above, some firm databases may contain pertinent and backup engineering data needed by FEMA contractors, and FEMA mapping partners for FEMA contracted flood studies and mapping projects, community-initiated map revisions, or map maintenance activities. The firm database includes information needed for core NFIP functions, such as insurance rating and compliance monitoring. The firm database includes sufficient data to allow users to reproduce the flood profiles and water surface elevations. Additionally, the firm database stores original products and intermediate products of high value and/or wide applicability. The firm database does not include all intermediate data developed in the course of conducting the flood study and mapping project. Some of the firm database features may be stored in GIS mapping layers or related tables, but not shown on the paper firm product. The non-regulatory products created through RiskMAP watershed studies include the Flood Risk Database, the Flood Risk Map, and the Flood Risk Report. These products do not seek to replace the regulatory products, the firm database, flood insurance study, and the firm. Those will continue to be produced for each watershed study. The non-regulatory products are intended to provide additional information to increase flood risk understanding and awareness, risk communication, collaboration, and mitigation. The Flood Risk Map provides a visual representation of the potential flood risks in the watershed. The map contains the location of dams, levees, areas of mitigation interest, emergency routes, stream flow pinch points, information regarding the study areas, floodplains, watershed information, major routes, streams and rivers, and municipal boundaries. The data for the map is stored in the RiskMAP database. The Flood Risk Report provides an overview of the watershed, including information regarding the flood risk in the area. Section 1 provides an overview of flood risk and the flood risk products. Section 2 explains the methodology for the flood risk analysis results. Section 3 provides a summary of the risk analysis results for the entire study area and each community. Section 4 provides information on ways to reduce risk, including potential mitigation actions and grant funding opportunities. The data supporting the Flood Risk Report is located in the Flood Risk Database. The Flood Risk Database provides a framework for storage for the datasets. The Flood Risk Database is the product that contains the raw data and results from the flood risk assessment analysis. It includes all of the datasets generated for a community, including the changes since last firm, areas of mitigation interest, flood risk assessment, and flood depth and analysis grids. The Flood Risk Database will be the flood risk product that will contain the results of the following flood risk assessment data: average annualized loss, or AAL, using HAZUS for the entire area, refined HAZUS results for areas restudied, composite flood risk assessment, analysis required for flood risk assessment data in the Flood Risk Report, analysis required for flood risk assessment data in the Flood Risk Map. The features and benefits of the Flood Risk Database include a single source of complete risk assessment analysis, refined HAZUS loss estimate, and a useful tool to effectively identify and communicate flood risk. For RiskMAP projects that include regulatory products, the firm and FIS, the proposed NFIP map changes and impacts phase will occur. The objectives of this phase are to plan for preliminary firm release, build consensus with communities on impacts as a result of changes to the regulatory map, and encourage mitigation implementation and use of available resources. Activities that occur during this phase include sharing the proposed changes since last firm dataset, planning for preliminary firm and FIS release, and building an understanding of the impacts resulting from changes. For RiskMAP projects that include regulatory products, the firm and FIS report, the preliminary map release and mitigation planning phase will occur. The objectives of the preliminary map release and mitigation planning phase are to share the preliminary map with the communities, reinforce the use of the RiskMAP products, provide information on the value of and timeline for updates to mitigation plans, and solicit commitment to act. Phase activities include releasing the preliminary map to the community or communities as planned and discussing the value of updating the mitigation plan with the latest flood risk information and the timeline for plan updates. Watershed stakeholders have the opportunity to submit protests and appeals of the preliminary maps. Appeals are scientifically backed disagreements to the map data. Appeals apply to base flood elevation values. Engineering data must be provided by the appellant to negate mapped information. The appeals period lasts 90 days after the second publication of the FEMA publication notice in the community's local newspaper. Protests are all other mapping comments. Protest examples include stream names, road names, and corporate limit changes. The protest period lasts 30 days and begins at the conclusion of the CCO meeting and open house. The floodplain coordinator should direct all notice of protests and scientifically backed data to the Kentucky Division of Water. The Kentucky Division of Water and mapping partners will evaluate all protests and appeals before final maps are presented to the community. After the conclusion of the protests and appeals period, letters of final determination will be sent to communities and the adoption period will commence. Final products, including regulatory and non-regulatory materials, will be delivered to the community. The objectives of the Due Process and Path Forward phase are to empower the communities to share information with local citizens about the community's flood hazards and risks, to review new proposed maps, actions taken and planned, and the individual's responsibility to manage their own risks, and to encourage identification of short and long-term efforts to progress towards increasing flood risk awareness and management. Hazard mitigation planning is critical to the success of the RiskMAP program. Non-regulatory products identify a community's level of risk. It is the community's responsibility to educate citizens and utilize risk assessment products to build flood-resistant and flood-resilient communities. The overarching goal of the community is to lead and support states and local communities to effectively engage in risk-based mitigation planning, resulting in sustainable actions that reduce or eliminate risks to life and property from natural hazards. The ultimate goal for the watershed projects is to provide decision makers with the tools to take actions and mitigate risk. If more is understood about the watershed, then decision makers will be able to make more informed decisions regarding development, the sizing and location of infrastructure, among others, and how these impact neighboring communities in the watershed. In addition to the products available from FEMA, the Kentucky Division of Water is developing a Kentucky Risk Communication Toolbox. Portions of the toolbox can be found on the Kentucky RiskMAP channel on YouTube. In addition, the Kentucky Flood Information Portal is being developed and will provide the firm and FIS as well as supporting engineering analysis for regulatory products. The use of social media, including Facebook and Twitter, is being implemented to communicate risk mitigation programmatic activities and updates regarding disasters in the Commonwealth. For more information, contact the Risk Communication Specialist for the Kentucky Division of Water. Digital flood studies references are available on FEMA's website. This concludes our module on the life cycle of flood studies.